to our webinar today, How to Think Multi-Cloud with RightScale. Before we get started, we're actually going to ask the audience a few questions. So let's get started with our first poll. So if you could take a moment and let us know if you are using cloud infrastructure today. So infrastructure as a service tools such as Amazon EC2, Rackspace, etc. Just select the one that applies, whether or not you're in the cloud and you already have a couple applications in production, maybe you're getting started, or maybe you're just beginning to explore, or maybe you are not in the cloud at all. Just let us know. We'll keep this open for a few more seconds to give you guys a chance to answer. And let's see results. Oh, excellent. It looks like the audience here today has a lot of experience with the cloud, and several of you have one or more applications in production. That's fantastic. And then the next question. So what are your reasons for considering multi-cloud architecture? Select all that apply. This is a multiple choice, multiple selection question. There's several different reasons that we could think of why you would be considering multi-cloud, but GoToWebinar only allows us 5 different choices. So look through this list. If there are some that are applicable to you, select that. But maybe you're thinking of multi-cloud for other reasons. If that's the case, go ahead and actually you can send that in via the chat function, or maybe you have some questions for us. You can post those as well via the questions panel. So we'll keep this open for a few more seconds. Oh, interesting. It looks like there's a pretty even distribution between all of these reasons, and I'm sure that many of you actually selected multiples of these. That's fantastic. We'll actually be talking about these today. So let's go ahead and get started. Just quick introductions. Our team here today, we've got Michael Crandell, our CEO and founder of RightScale. We also have Giuseppe Blanquer, our senior systems architect and a very important thought leader in this multi-cloud space. I'm really excited to be hearing more from him today. Also on our Q&A line, we have John Newton, our account manager. So we'll be answering your questions behind the scenes throughout the course of this webinar, so just go ahead and ask your questions at any time. And we'll also be picking some of the questions that are more broadly applicable and addressing those live on the air and having Michael and Giuseppe answer this for you. So Michael, let's take it away.
Great. Thank you, Sarah. Looking forward to doing this with you today, Giuseppe, because there's certainly a lot of interest in multi-cloud. Before I dive into what we're going to be talking about today, just a quick side note. RightScale has a couple of events coming up today and tomorrow for those of you who happen to be in the Bay Area. We have our first user group meetup for the Bay Area RightScale users group occurring tonight. And then tomorrow we have kind of a presentation and networking event called Clouds, Conversation, and Cocktails that we're co-hosting with the private cloud company Cloud.com. Also in the Bay Area. The specifics are on our website under News and Events. So there's no charge for these events. You're most welcome to join us. But let's get to the subject for today. So wanted to tell a bit of a context and story around multi-cloud, the reason that we decided to do this webinar. I think we're all aware that cloud computing has come to a point where there are so many different clouds, quote unquote, out there in the landscape. There are many different APIs, many different product offerings and infrastructures are called clouds. We now speak of public clouds, private clouds, internal clouds, external clouds, et cetera, et cetera. And we see that the landscape has shifted to be very much a multi-vendor, multi-player world. So since that's been a focus of RightScale from the very beginning to allow our customers to take advantage of multiple clouds, we decided to focus in on that. Also, I think that 2011, while there's certainly a lot of clouds out there, I think we will see 2011 next year emerge kind of as the year of multi-cloud, and as companies begin to leverage these multiple resource pools that we all have access to now. So what we're going to attempt to do in this webinar, it's some overview, but also diving into the technology of really how you should think about multi-cloud. Because multi-cloud is more than the notion that you just talk to a different API on a different cloud to launch resources. It's more than the notion that you have an interface where you can click a button to launch a server in resource pool A and click a button to launch a server in resource pool B, and that somehow magically means your problems are over. There's a lot more texture and complexity to the world of multi-cloud than that, and that's what we're going to be diving into, as well as providing a live demo of what it looks like to manage and utilize different resource pools. Then, of course, we'll give you some time for question and answer. So now I'm going to hand off to Josep, and Josep, take us into how to think multi-cloud.
Thanks, Michael. Let's see. Basically, the outline for today is I want to first give a quick definition, so to speak, of what do we mean by cloud in the context of this talk, and then speak about some of the things that are different when you actually use different clouds at the same time, and how RightScale can help in making you both think and actually use these different resource pools within the multi-cloud space. We'll have a demo at the end, but if you have questions about some of the things that I'm talking about in the middle, we can go ahead and maybe demo it or answer it on the spot. So feel free to ask the questions whenever you think of it. So let's start by defining what do we mean by multi-cloud from today's talk's perspective. The important thing there, I think, is to understand that a cloud, it's really a physical thing. It's a pool of resources. It's something that you can manage that exists in real life. And usually you manage that through an endpoint, an API endpoint. Some clouds call it the cloud controller, call it whatever you want, but it's basically something that exists out there in the world. So I'm saying that because basically it's important to realize that a cloud is not something like Amazon Web Services. Amazon Web Services is just a set of services. EC2 even is not a cloud. EC2 is just some sort of an API definition to manage VMs in a particular way. Even software like Eucalyptus or Cloud.com or vCloud are not really clouds. Those are just software that can allow you to create a cloud. What really is a cloud is things like EC2 East, a region, what Amazon calls it, or EC2 Asia Pacific, or your private cloud in your garage. Those are clouds, right? They have an endpoint that you can talk to that allows you to start machines, to create volumes, to attach drives, whatever the cloud API allows you to do. So it's also important to know that an availability zone from a Amazon perspective is not a cloud either. It's just a little region of a cloud, or it's a part of a cloud. So the key point here is that you can think of a cloud, or you should think of a cloud as a resource pool that can be accessed to an API. So what does that mean from that perspective? It means that these things exist somewhere in the world. So, and I guess that one of the first things that people can think of is that, well, there are just a small subset of big clouds that exist in the world. And what we could think of, like this slide kind of tries to portray the fact that there's some big vendors there that have some big cloud centers scattered across the world. And then we just put some different colors here to define the fact that, as Michael was saying, there's going to be more and more vendors creating big centers around the world in the upcoming years. But this is not really all the landscape of the multi-cloud area. The real landscape is not only the fact that there are big vendors, but there's going to be many private clouds, or at least non-public clouds out there. So the landscape, I think, it's important to realize that we're not going to be interfacing, we as in the users, we're not going to be interfacing with just a few big clouds. We're going to be interfacing with many different clouds. Okay, so what does that mean from the point of view of RightScale? How do these clouds appear? Or how can you start managing these clouds in the RightScale dashboard? Well, as soon as you add a cloud, you'll see that that cloud, it'll appear in your clouds menu. Here in this slide, you can see that there's like 1, 2, 3, 4 AWS clouds, 1 cloud.com cloud, and 1 Rackspace cloud in the menu. In each of these cloud menus, you can see that you can manage the resources within them. So let me just give you a quick, show you a really quick how that works, how that looks in the RightScale dashboard. So if you go to the normal dashboard, you can actually see, this is a test account, so there's all kinds of things happening. I'm going to close this tab here so we do not get distracted. In the clouds menu for this particular test account, we can see that we have all kinds of different clouds registered, from Eucalyptus clouds to cloud.com clouds to AWS clouds to some prototype clouds that we have. Okay, so one of the things that you can see, for example, is that if you go to your account, there's a clouds tab that you can access that tells you for this particular account which clouds you have access to. As I said, this is a test account, so there's all kinds of things that are really prototypes and testing here. But the key point is that you can add clouds fairly easily for the ones that we support, for example, with a few clicks of a button. So if I click the Add Private Cloud button and then decide to add my Eucalyptus cloud that I have just installed in my basement, if I provide my name and the typical registration URL that I get from the cloud vendor that I just installed, then I can complete that piece and the cloud will basically appear in the clouds menu up here. So that's kind of what it means from the RightScale perspective in managing your clouds. So we get back to the presentation. As soon as you have registered your cloud, you can start using it like any other cloud. Okay, so that's for the clouds from basically the cloud definition perspective. So the next thing I want to do is to talk about what does it mean to go multi-cloud. And basically the first thing I want to say is that there's the highfalutin answer to that, and then there's the more earthy answer to that. So let me start with the high vision of what going to multi-cloud means. So going multi-cloud is really about deploying your application across different clouds, which most likely can span different cloud providers, which can potentially have very different APIs, which could even include private and public ones. Not only that, but also as your application evolves, you should be able to incorporate new clouds as they appear, or move and shift resources from cloud to cloud. And the key of all this is that all this should be done basically seamlessly. You don't have to reinvent the wheel every time that a new cloud comes on. You should be able to manage everything in the same way, using the same abstractions, and all working together in an integrated manner. So in some ways, you can think of going multi-cloud, not just the fact of being able to choose which cloud or which provider you want, but you should be able to use multiple of these providers. Right? I don't necessarily consider you having a choice of 10 providers to be able to say that you are multi-cloud. You have to be able to use more than one at the same time. Now, the more earthly version of this is what can you do right now from the multi-cloud perspective. And I think that a good way to think about this is about cloud portability. Yes, you can have all kinds of applications running on different clouds at the same time, and everything could be, high availability and high replication redundancy. But today, I think that the first step towards going multi-cloud is to be able to launch deployments in different clouds in a way that you can manage them in the same way. Not necessarily build your application that is simultaneously running on different clouds, but at least you can deploy your app in cloud A, or you can deploy your app in cloud B exactly in the same way, and managing it in the same way.
All right, so let's, Joseph, let's zoom up just for a second. You talked about from a down-to-earth perspective, what's really practically possible today, and just to emphasize why would somebody want to use multiple clouds, because certainly we have customers who use a single cloud and they're perfectly happy with it. So why would you want to consider multi-cloud? Well, there are a couple of key benefits to keep in mind, and if you are using one cloud today, you might just keep these in mind for the future. At the end of the day, all of this is about freedom of choice and the ability to choose what you need when you need it for the reasons and requirements that you have inside your organization. So one obvious one is around redundancy or resiliency. The notion that you could create a disaster recovery, kind of a small footprint version of your application in a second cloud for business continuity purposes, and then if something goes wrong with the first cloud or something unexpected happens, you can switch over, maybe switch the DNS over, and you've already got a footprint running and you can scale up elastically from there. So that's one kind of scenario. Also, the same thing applies to running in a public-private hybrid scenario. If you have something running internally and then something goes wrong with that, you could move it external or vice versa. Geolocation is a really important benefit. If you're serving populations around the globe, you may find that latency is a problem. Trying to serve, for example, an Asian customer base out of data centers in the U.S. It doesn't matter whose cloud it is, there are certain laws of physics at work that you can't circumvent that are going to mean latency will be improved if you get a data center over closer to your customers geographically. Another one is around policies, political compliance. So, for example, many European customers want to use data centers, cloud data centers that are inside the European Union for privacy policy reasons and privacy laws. One of the things we've enabled is the ability to leverage cloud-specific services when needed. So we don't, in effect, dumb down or reduce the functionality that's exposed for any given cloud to a lowest common denominator. Rather, we enable the richness of each cloud. Just to pick an example, Amazon's Elastic Block Store with snapshot functionality, very powerful kind of backup functionality, is something that's exposed in our system that you can utilize. Of course, you might want to supplement what you're doing with internal data centers with something external because there are cases where that's cheaper, or the scalability that you can get with an application that requires unpredictable or varying load can also represent cost savings. On the obverse side of that, you might want to leverage an existing data center because you already own it, it's already built out, it may have additional capacity available. So that makes sense in circumstances. Of course, moving bursty or unpredictable load applications to a cloud that's bigger than what you have internally also makes sense sometimes. Sometimes private cloud makes sense because of security concerns or regulatory compliance. If the law in your industry says that you need to have resources running inside your four walls, then that's the law and you should comply with that, and it may mean that a private cloud is good for at least for those applications that need to be compliant. So those are some reasons around the benefits side, but in order to gain those benefits, you have to face architecting for multi-cloud and supporting that technologically. And what are the pain points there? Well, one of just the beginning is that there are different APIs to different clouds. There is no standard API out there, nothing even close in our view. So the APIs differ for a starting point, but that's really just the beginning and the most trivial challenge that you'll have to face. As you dig deeper, you find out that resources within different clouds, and there I'm speaking about servers, server behavior, storage, etc. The resource behavior differs between different clouds. So you need a way to map application function that's using resources, such as storage in a local disk on an instance, a virtual server. Is that local disk, does it persist beyond the run of that server? Does it not? Is there any sort of mountable external storage or very redundant but slower distributed storage behind that? Just to pick one example. IP address behavior is another, networking behavior, etc. So all of that resource behavior varies. The formats and encodings that are used also vary. The versions that you may deal with, versioning within a single cloud may vary, and the list kind of goes on here. You can see from the bullets that everything from network address translation, how security groups, VLANs, etc. are handled, all of that can differ. Different hypervisors are used by different clouds, and the formats for launching machines in terms of basic machine images also differ among clouds. So the list kind of goes on, culminating with cost models, billing, reporting, etc. There's quite a bit of complexity to realizing the goal of freedom that we talked about on the previous slide. And really you end up dealing with almost different applications that have different semantics. So I'm going to pass back to you, Josep. What do we do about that?
Yeah, before getting to this sort of, I guess, best practices points, there's a couple of questions that came in that maybe I should really quickly respond to. One question is, what kind of latency issues will geolocation solve? It seems that geolocation can increase latency. Well, what we meant by geolocation is that you want to locate your servers close to your customers. It's not the latency between your servers. Right? You want to have your bookstore for European customers in Europe, and you want to have your bookstore for the US East customers in US East. That's what we meant by geolocation. Another question was, does cloud portability mean moving from AWS to Rackspace and vice versa? No, not necessarily. It means being able to do exactly the same thing, being able to launch your application in AWS, and if you decide to, launch your application later in Rackspace in exactly the same way.
With the minimum amount of extra work.
Exactly, in the same way. It really should be, in the ideal world, would be kind of a switch box or a choice right here. Okay, so that out of the way. So let's talk about what is different when we go multi-cloud. What pieces of the puzzle should you be thinking about when going multi-cloud? And by preparing, when I prepared the first set of these slides a few weeks back for another talk that we had, I sort of realized that in a way it shares many of the challenges that you would have if you had to create an application made out of different, sub-applications that speak different languages. In a way, designing your application using several programming languages, for example, right? There's very similar things you'll see in the bullet points. So one important thing is to think about deploying your application using cloud specifics, but really designing your application using generic concepts, right? Utilize, as Michael was saying, utilize the features that you need, that the cloud provides. There's very powerful features that cloud provides. Not all cloud provide them, but if you can take advantage of them, use them. But don't lock yourself in depending from those features. So that's a very important point, I think. Another point is that you need to have tools that translate your concepts, these high-level concepts that you have designed, into the cloud-specific ones. I'm not talking just about having tools that translate your concepts into API calls. I'm talking about things that allow you to talk about your concepts at a higher level. So like, for example, if you design your application and you have this, you can call it a backup concept, a backup of your database. Just use that concept across clouds in a way that allows you to map it to an EBS snapshot if you're working on Amazon, or a tarball into a cloud files sort of scenario if you're working in Rackspace, right? Have those things that can do the translation however you need it. Another point here is that it certainly becomes very important to design your application for geographic dispersity. Clouds are isolated. Therefore, the networking across clouds is not as cheap as networking within the single cloud. So these things, depending on how much bandwidth or latency you need in your different apps, these certainly become important. Communicating and moving data across the clouds can be very, very expensive. So you have to have that in mind, something that usually within a single cloud you can put aside, so to speak. Another important thing that is related to this is that you have to start thinking about how to share data across. Again, clouds are very, very isolated, so you're going to have to know how to share data across if you have to share data across. And this, again, becomes more important when you're actually having applications that have high availability rather than the typical or the simpler portability examples that I was talking about. So you have to know how to share global storage, how do you do periodic backups, you can go from one to another, how can you do like live replication of data perhaps, in case you want to take over like a slave database into a, to become the master, things like that. Those are a little more challenging when you're talking about communicating across different clouds. And finally, kind of it's a bit of a higher arching theme is that know if you're designing your application for portability, like to be able to launch application A in Cloud 1 and application A in the same way in Cloud 2, as we were talking about in the case of Amazon and Rackspace, for example, from the question, or know if you're designing the application to go multi-cloud in a more holistic sense, in a way that you can have your application running simultaneously in, say, 2 or 3 clouds, and have your services talk to each other and always be in sync, such that, say, a whole one cloud goes down, the rest of your application continues to work. That's a much more challenging thing, and as I said before, the best thing to do is to start working on portability first to be able to bridge the gap between all the differences across the different clouds, and then once that's sort of solved, so to speak, then you can start thinking about doing these more high availability scenarios. Okay, so with that, so let's take a look at how RightScale can help you in both thinking on these multi-cloud abstract terms and actually helping you in managing your applications through the dashboard. So there's basically 3 things or 3 concepts that I want to focus on today. In particular, RightScale in general will allow you to manage resources or concepts at a higher level overall in the dashboard. But there's 3 things that are very important when you go multi-cloud. Number 1 is the runnable abstractions, what we call servers or server arrays. Server arrays, for the ones that are not used to, is basically an abstraction that allows you to increase or decrease the pool of instances or servers running based on some load characteristics or however you want to define your array. It's basically things that are running on the cloud. The other one is the server templates. Server templates are a configuration level that allows you to say how you want your server to come up with in terms of software configuration. And the third one is the concept of which images, which base bits or base VM you want to put when you're starting a server. So we'll see that these things, if you abstract them outside what the cloud specifics, if you abstract it outside what the cloud provides, then it allows you to really map it to different types of resources across different clouds. And that's kind of the key of this multi-cloud talk, basically. So let's start by taking a look at the servers. The servers and server arrays, as I said, are runtime abstractions that represent servers, the VMs, so to speak, that will run in the cloud. And the key here is that if you use servers and server arrays in our dashboard, they will really look and smell really, really similar, regardless of what cloud they belong to. You will be able to start and stop services, run scripts, and which means like run some sort of process on a server in a very, very similar way, regardless of the cloud. All of them will have monitoring data in the same way. You can configure alerts that can alert you when certain thresholds go over certain lines. You can have servers in the same deployment that belong to different clouds, but they really look sort of mixed together nicely. And then at the same time, if you work at the server level rather than at the VM level on the cloud, it allows you to basically change or support some features that the cloud does not provide. But the server, which is a higher level abstraction, can somehow make it appear as if as it does, right? So basically, servers can be really different beasts from the point of view that they will really be mapped to very different VMs in different clouds. But if you use them in RightScale, they really look like servers, basically, regardless of that. So the next thing is the software configuration abstraction, which we call server templates. But before getting into the gotchas of server templates in the multi-cloud environment, I'll hand it to Michael so that he can explain a little bit what they are.
Sure. We just want to take a quick detour around what are server templates, because they're a key conceptual building block in this multi-cloud picture. Server templates deal with the problem that was essentially the benefit and the problem that was simultaneously created by virtualization, which is one of the core building blocks of cloud computing. It's the notion that servers were based on machine images. And these machine images tend to be multi-gigabyte disk files representing a frozen state of a server with all of the variable and specific information in the context of that server kind of baked or frozen into the image. And so we discovered from very early days in working with the elasticity of cloud and the ability to launch new resources so quickly that we were constantly modifying the way servers behaved, because anybody who's developing an application or operating an application know that it changes over time. So we ended up with so many different copies of machine images, we discovered it was a kind of an awkward level of granularity to be working with. So what we decided to do was build a new framework that changes from this example is just a whole collection of frozen bundled images into a different way of configuring servers. And on the right-hand side of this slide, you see that a server template is the notion of starting from just a couple of very basic operating system-based machine images. So we still use machine images, but we restrict what's in the machine image to the plain vanilla OS and perhaps a handful of utilities that are extremely common across all apps. And then a set of configuration directives that dynamically configure the server at boot time, during runtime, and during decommission to specify the behavior you want and for that server to basically take on the identity and role that you want it to take. So during boot time, what happens is that RightScale, as the server is booting, the server communicates with RightScale and receives the instructions of what scripts and components it's supposed to load. It then goes from this sort of framework definition or template definition, hence the word server template, into an actual running server where the various components have loaded and whatever variable or setting information needed to be communicated for that to become a specific instantiation of the server happens. During the boot sequence, the same thing can be specified during runtime. We call those operational scripts. They can be launched manually or automatically at any time during the operation of the server, and then the same thing when the server shuts down. So that's a little sideline into server templates, and now we'll go back to how those are utilized in multi-cloud.
Yeah, so basically what turns out to be is that server templates are really just, they really bridge a gap between a starting point, what Michael was saying, sort of a base image, and a fully configured machine. It's really the list of directives that at boot time the server will have to execute to get to the point that you want it to be. So these directives can actually be very much multi-cloud and multi-OS basically aware, right? If you build a template that knows to basically see which cloud is booting at and what operating system he's actually using, and can bridge the gap between the differences of these clouds and operating systems to the point of installing whatever it needs to install, suddenly you can define server templates that you can boot on different OSs and different clouds, but that at the end of the day end up with exactly the same configuration that you want. So that's basically the key of the server templates, and in particular the multi-cloud server templates. We don't really call them multi-cloud server templates because inherently they are multi-cloud if you program them in the right way. So something else also that is important here is that these abstractions of server templates are configurable. You can configure, there's a bunch of input values that we call them configuration values that you can pass in to basically customize the template to your liking. You can pass things like what DNS to use when you boot up, say, your MySQL server, or what host name you want to support for your Apache configuration, things like that. If you do them right, they can also partially help in the sharing of data, because you can think of situations in which, for example, if you're bringing up a PHP app for a developer, maybe he has to restore some sort of a database dump for testing purposes, and the template in one of the scripts could actually go and get a tarball or a MySQL dump from a global system like S3 or cloud files in a way that you boot that template, and regardless of where you boot it, you're going to get the data into the server. So they can actually help in the sharing of data. We built all these server templates in a way that you can version them and you can actually publish them for your own users of your accounts, or even you can publish them into our server template library service so that other users can actually take advantage of what you build. So if we have some time later, maybe in the end, we can show the server template library and see. You will see that there's many people that have published open source templates that you can very easily go import into your account and boot a server with. Say, for example, from a WordPress template to, I don't know, Rails templates, things like that. You name it. This is only going to increase over time. So at the end of the day, basically, server templates allow configuring servers always in the same manner, or at least in an equivalent way. So the key here, the key missing piece, is that a template has to specify which starting point, which base image needs to use. And this is where the multi-cloud images abstraction come in. If we tied a particular template to a particular cloud image, then we would be tying a template to only work on a particular cloud. So instead, what we have done is we've introduced this other concept of a multi-cloud image, which is really a way to define what requirements you would like from this base image perspective. And then, for example, we could have a multi-cloud image called CentOS 5.4, which means, all right, regardless of the cloud you're in, I would like to start from a 5.4 base image when I boot this server. So basically then the missing point is that you have to have a mapping between these requirements, CentOS 5.4, and each particular image in each of the clouds that you want to put the template in. So MCIs really are an equivalency map between what you want, CentOS 5.4, and particular images in the cloud. Say it could be image AMI FFFF in EC2 Cloud, and it could be image 1234 in Rackspace. But if you boot either of these images, they will come up with a CentOS 5.4 image that you want. It will serve as a base starting booting point for your server. Again, we've done this in a way that they are versionable and publishable, so that you could, as an organization, you probably would like to have a few MCIs for all your users to use, and then maintain and evolve these mappings as you introduce new clouds or as you rev up your base operating system images. So basically what you do is you associate a multi-cloud image in a server template, and you say this server actually uses this server template, which in turn will define which multi-cloud image to start with. And that's basically the full circle of configuring this in a multi-cloud or a cloud agnostic way, so to speak. So before getting into the demo of everything, also you can see in here this slide is just a screenshot of a listing of multi-cloud images that we actually publish for all the RightScale users, and you can see there's all kinds of multi-cloud images for Windows, for CentOS, and in the middle of the screen you can see that a given multi-cloud image, say, let's take for example the first one, Right Image, Windows 2003, it has mappings for basically all AWS clouds for EU, East, West, etc. We'll see more of that in our live demo later, but that's basically the gist there. Okay. Before getting into the demo, I also want to do a couple quick points that are important when you go multi-cloud, and this is about data locality and mobility. In particular, I just want to point out that this is a topic a bit further down the road, but it's good to start thinking about it. And the big hurdle here is that when you're dealing with multi-cloud, moving data is very expensive because clouds are really isolated. So you have to start thinking about how you want to share data across them. And there's many different ways that you can actually do that. You can use things like external services like S3 or cloud files to really boot a server and always go to that central point that is global to get the data that you need. But that only works for small pieces of data or pieces of data that you can probably incrementally download. It doesn't work if you want to download 200 gigs of data for your database restores. You can also transfer data snapshots across clouds, maybe even putting together some replication strategies that incrementally you will back up things from one cloud to the other so that at least you have most of the data in one of the clouds in case you have to recover it fast. Things like MySQL replication, for example. Or you can also try to use things that are inherently much more replicated, like any of the NoSQL databases that basically take into consideration that there's a divide between different clouds, so they have different bandwidths across them, but they still know how to keep the two pieces or the end pieces in sync as time evolves, so that you can always have a network partitioning in the middle, but still have most of the data basically on the other end. So it's important to know which applications or which strategies you can use to share data. And last but not least, I also want to point out that it's not only about moving data, but also keeping track of where it is. When you have data that is important to recover at some point or to move from cloud to cloud, you have to have strategies that allow you to know where it is. Think of a database backup. You're going to have many backups along the way of the application lifetime. You have to know where they are. If you restore or you promote the slave to a master and it's in a different cloud, well, suddenly the lineage of those data pieces have moved from cloud to cloud. So the latest restore now is probably from cloud 2 because that's where your master is right now. So it is also very important to have that into consideration, and we're actually working on some of these new multi-cloud abstractions to help you with that. So that's just some food for thought. So let's get maybe down into the use case and then get into the demo. So the use case that we have here for today is cloud portability. As we said, kind of making you think about some building blocks that you can start building your applications with, and then allowing you to deploy these building blocks in very much the same way across different clouds. So this case for today would be, for example, say a company that has blogs, a blog service, and you would have you were going to use say an AWS service in the West Coast for US customers for your service in a typical, couple load balancer boxes plus an array of app servers in the middle and backed by a master-slave database, a very typical example. And maybe you can even want to do the same thing for your Europe customers in a completely different app, right? Not that these applications are not necessarily talking to each other. They're really the same thing with different sets of customers, right? It's a cookie-cutter sort of model. Another thing you could do is say, well, for disaster recovery purposes, I may want to have the same sort of setup, say from a Rackspace data center cloud perspective, maybe in a smaller way, like just with less servers. Maybe I don't need the MySQL replication. And finally, you may want to have exactly the same thing for your developers that are, say, in New York. So you want to have your private cloud, say, for example, with cloud.com, and have all your test and development using your private cloud. So I don't think that this is an unheard sort of case, I think it's, you know, from a small sort of business perspective, I think that makes sense. So how would you think about putting that together? So as I said, it's kind of a building blocks sort of approach. You would have to start doing scripts and recipes. Remember that these are the things that you plop into a template that will be executed at boot time. You create these scripts and recipes, say, for example, that they can know how to configure a load balancer piece, or to enable PHP into the Apache modules, or to install and configure MySQL. You build these ones, and then you put them into different templates. And then the idea here is that in some templates, maybe you only want to have the MySQL piece, because MySQL machines in production will run alone in its own box. But on the other end of the spectrum, the developers don't need to have a multi-server deployment to test. They should be able to boot one single VM and run it all. So in a way, then you want to plop in the load balancer, the PHP piece, and the MySQL in the same place. Once you have these, then you have to choose which images you want to boot from. And that's where the MultiCloud image comes into place. And for this particular example, maybe you want to deploy everything in your 5.4 CentOS machines, which will definitely have mappings into the different clouds that you want to deploy. So once you have all these building blocks, you basically put together these things into servers. So you say, I want a server that has this MCI running this template, and that's going to basically be a server role in your deployment that you can start. So that basically maps into the servers that we had there on the left, right? So we'll have several servers for deployment, for the production deployments. We will have less servers for the beta, say, and the test and dev deployments, right? So every developer maybe only have one server that has everything. But note that everything is built with the same building blocks. So as your developers rev the templates and add things to the templates and change the scripts, you version these things, you publish these things, and eventually the same exact things will make it into production when you upgrade the next time. So that's basically the idea of the building blocks and then putting them together for different purposes. So we have a bit of a demo about that. So let me bring this over. Okay, so that's where we were before. So the demo is the following. So I have a deployment, and this basically puts together everything that I've been talking about, not just this example demo, but all the concepts of the MCIs, the templates, and the servers. So in this demo, basically, it basically mimics the production deployment that I had in my slide. We would have each row of this listing is a server. All of them, in this case, are in the US East deployment of Amazon. We will have 2 load balancers. These are the names of the servers: WordPress LB1, WordPress LB2, 2 databases, a master and a replicating slave, and then we'll have 1 app server. In a normal case, we'll have many app servers depending on how much load you need to your application. So this is an example of a WordPress template that actually we can go and see that it's working. It's already loaded. Okay, so this is working. I hope that this is working. Let me see. Yeah, okay, so this is something that is actually working in there. Good. So the key here is the following. Let's take a look at the different templates that we have. We have a load balancer template, a database template, and an app server template. And actually, if we look into the contents of these templates, we'll see that we have reused the same building blocks of the scripts that I was talking about. So before that, I'm going to show you that this is not a rig thing. Let me relaunch the app server really quick, and while I'm going through the application, it'll have time to boot again. So I'm going to relaunch it. I'm going to launch it immediately, and then we can see that the block should disappear, basically, or should fail. Because since I only have one app server, there's not going to be redundancy in this particular one. So if I reload this, this is going to take a moment to really go down. Okay, so let me see what's good to explain here. Another thing that I have in here while this guy goes down is I've put together also in the same deployment another server that has an AIO, an all-in-one template that basically has everything in one. Right? On top of it, to simulate what would be the developer deployment that I had in my slides, I have another different deployment that only really has AIOs. So this would be a deployment that, for example, my developers would use. Note that this is exactly the same server template, but it's really using, it's deploying in a different cloud. This is a private cloud deployed with cloud.com software. But it's basically the same exact template.
So just to pause for a minute and emphasize that. It's the same template, it's the same application, but running in a completely different resource pool,
right.
Infrastructure, different cloud architecture.
Right, exactly. So I cannot really log into that particular box because this is actually a real scenario. These are private IPs. So if I was within the developer group of that cloud.com cloud, I would have direct access to these private IPs, but we're outside. We're out of that private cloud. Therefore, I cannot go directly. I would have to go through a gateway.
For the purpose of this webinar.
Yeah, but if I was a developer, I would be inside that network, so I could quickly go to it. Okay, so let's see if this guy has already started decommissioning. I think so. Okay, so this says, load balancer says, no, there's no app server that I can forward the request to. So you'll see that as soon as the machine is rebooted, the service will be up again. So this is just to show that we're using this deployment and not something else, basically. So now let's take a look at something interesting. So if we open up the AIO, the all-in-one template, we can see here in the scripts tab, we can see basically what Michael was talking about all these scripts that are going to be executed at boot. There's things like setting up the time zone, installing MySQL, installing Apache, creating the virtual hosts, restoring a backup from S3, all that kind of thing that the server will do when it boots. So let's do a diff between this one and the the app server. So the app server is only the PHP side. It does not have the database part that the all-in-ones have. So in here, just a quick way to show you that are basically using the same building blocks. So most of the installing the monitoring, the keys are the same thing. So the all-in-one has many more things. Like for example, it installs MySQL and it sets up the right privileges and adds MySQL monitoring. So those are the new things. There's a couple things that are slightly different from an AIO to a non-AIO, but most of these scripts that are in white are basically the same. So we're reusing that piece. And then lastly, so we can have some time for questions. So if we go to any of these templates, we can see that it defines a single multi-cloud image. We call it MultiCloud Demo CentOS. You'll see that it supports all these clouds. Let me actually show the Clouds tab of the multi-cloud image. So here, this multi-cloud image has mappings to AWS Asia Pacific, EU, East, West, Cloud.com, and even Rackspace. We're not using any server in Rackspace for this demo, but it's basically, this is all the mapping that I was talking about, the abstraction of a multi-cloud image in my previous slides.
So that's really what we're seeing there is the ability, again, to state the obvious, to access all of these different clouds whether they're private internal clouds or public external clouds, from a single pane of glass, as it were, from one interface.
Exactly. And all these things, even in this deployment, all the servers are done, are managed in the same way. The monitoring is the same for all of them. Exactly the same thing that you would see here in the cloud.com deployment. If I hide this column that says cloud.com, that says which cloud this is deployed on, you would really see no difference in how you would manage a server. You can come into a server, you can take a look at the monitoring for that server. It's exactly the same. That's the thing that we said before.
Perfect.
I'm not sure if this has booted again. Maybe it's too fast. It hasn't booted yet. But anyway, so maybe we should open it up for more questions, or I can just recap.
Yeah, why don't you go to the quick recap and.
Okay. So really quickly, just a little bit of a summary of some of the things that we said. Part of it is basically best practices. It's important to work with generic abstractions, but really deploy using cloud specifics. Avoid lock-in, but by designing the high level, but really take advantage of everything. So the RightScale approach to this is what Michael said. It's like we don't want to settle by this common denominator. We want to make things smooth across clouds, but we want to give you all the power that each individual cloud gives you. Another thing is build generic templates that can boot across multiple operating systems or cloud types, so that you can reuse them as much as you can. Keep a good and clean mapping of images, such that people only have to worry about which MCI to use. They don't have to worry about how this MCI maps to the cloud that I really want to deploy on. Know your data, know where it is, and track it, because it's going to be important when you go multi-cloud. And very importantly, start with portability. Start by building the blocks that allows you to deploy the same thing across different clouds before you really try to go all out and have applications that live simultaneously in different clouds talking to each other, because that adds a lot of complications. So just to, as a last point, as we did kind of when the cloud paradigm kind of came up to be, start thinking different again. I mean, going to a cloud environment makes you think differently. Going to a multi-cloud environment will make you think different even more again.
Right. Well, thanks, Joseph. I'm going to, I think we've got time for just a couple of questions. And meanwhile, here's some information on how to follow up. If you'd like more information, we have lots and lots of content on our website. You can see the pointers to the URLs there. Also strongly encourage you, if you'd like to share with us in the completion survey at the end of the webinar some of your thoughts about what you're trying to do in the cloud, what you're looking for help on. That helps us refine what we're focusing on at RightScale, and we'd love to hear from you about that. So please do fill out the completion survey. A couple of quick questions, and then what we try to do is wrap up close to the hour for the live portion, but keep the chat line open. Since we do have several questions, we're going to keep going for a few minutes here. The first one is, we are interested in multi-cloud redundancy and inter-cloud failover. Does RightScale support servers running on multiple clouds? For example, I would want RightScale server management functions to continue to work in the face of an AWS outage. And I think that's precisely the point. That's kind of the prototypical example here, is creating a portable solution so that you did have a redundant footprint of an application running in a second cloud or a third cloud even, for exactly that case of failing over from the possibility of a failure by one cloud provider. Next question was, how much should we rely on tools that exist only with a single supplier of cloud-based solutions? So, interesting questions. I guess I'd turn and point to what we hear from our customers and users, which is one of the drivers that's behind their choosing to work with RightScale is exactly that point. Not that there might be anything wrong with a single cloud provider's solutions, but what's driving them is the ability to retain freedom of choice, to avoid lock-in, and to choose what infrastructure they want to run for whatever requirements and reasons. And that's exactly what we try to enable. So if that kind of thing is important to you, I would say look at a solution that supports portability and choice among cloud providers. The other advantage is that RightScale remains an independent entity, and the RightScale community, including users and partners and customers, becomes a group of people and has become a group of companies that rely on independence from any given cloud provider for kind of a agnostic and independent view of what's happening in the clouds and what may happen in the future.
I have another question here that maybe I can take really quick. This question says, a single server template can access multiple different clouds regardless of server OS difference? Yes. In a way, you saw it in the demo. We have, if you build the template correctly with the right pieces, it will actually boot regardless of where, what cloud or OS you're having. Of course, depending on what the template needs to do, if it needs to configure, say, something from MySQL, some OSs have configuration files in different directories than others, so the template will have to be aware of which OS is booting and putting it in one or the other file. But in a way, you can build that as part of the template. And I also should say something else, that you can use write scripts, what we call write scripts, which are really any type of scripts. It could be shell scripts, it could be Ruby scripts, Perl scripts, whatever you want. But you can also start using chef recipes in exactly the same way. You would put a list of recipes in the template. Recipes are a concept for chef from Ops Code if you're not familiar with it. So, for example, from that perspective, there's many recipes in chef that exist, open source, that have already been built with providers behind them that do exactly that, know exactly which system or which OS they're putting in and configuring what you want in the right way. You're using the right files or directories or whatever.
Great. Here's another question, Joseph. How can you identify the vendor options within RightScale framework and weigh the trade-off of vendor-specific capability versus portability? And I'll take a shot at that. That's not a simple question in the sense that cloud capabilities, cloud infrastructures have evolved to become quite rich. So there are lots and lots of services that each cloud offers, ranging from storage, compute, data structures. Amazon just announced a DNS capability, IP address management, security, et cetera, et cetera. So what we typically do is it's part of the RightScale engagement with a customer to talk about those specifics. So I would say that today that's mostly addressed not in the dashboard itself, but in coordination with RightScale staff, RightScale knowledge bases, wikis, et cetera, where there's content and where you can discuss in an interactive way what are the advantages of using a particular function from one cloud vendor and what would it mean for portability. Some functions are much more easily portable. Others are much more, I'd say, proprietary to a given cloud vendor. Some of the very scalable data store solutions, Joseph, I think have very specific interfaces, things like whether it's Bigtable on Google App Engine or SimpleDB that aren't very portable. So it depends very much on the context.
Yeah. So I have two questions that are related. One question is about when you speak of expensive cost to communicate between clouds, are you speaking in regards of the data communication network bandwidth cost associated? Now, I'm not talking about cost. I'm talking about cost of moving bits, not in a monetary sense. I'm talking about that when you have things within a single cloud, you may get gigabit Ethernet bandwidths, and you take that for granted. When you go into a multi-cloud scenario, that's not going to happen. Now, another related question is, does RightScale provide ways to network between different clouds, or does this require manual setup? We do not provide that capability, but if a cloud comes up with some API that allows you to wire things up, we will support such things.
Yep. Here's a question, maybe a little bit ironic. How can a cloud fail if it's using cloud architecture? So I think the pointer there is that clouds are not magical. Clouds are a kind of infrastructure, architecture, and organization that still gets down to physical resources somewhere in a data center. But cloud computing has come to comprise everything from private clouds up through very large public clouds. And part of what you need to do is architect for redundancy and resiliency. For example, if you listen to the CTO of Amazon, Werner Vogels, he says plan for failure, and one of their practices there is to pull the power on different data centers from time to time just to ensure that failover works. However, there have been outages although brief, and the uptime has been fantastic. There are outages because clouds are hugely layered entities like any data center, and there can be a point of failure ranging from connectivity suppliers, even though it's redundant, through API servers and on and on and on. So I think at the end of the day, it's really your judgment within your company, how much risk you're willing to absorb, what kinds of SLAs you need, how much downtime is acceptable, and in what conditions you really want to be able to have alternative footprints running in another cloud for whatever reason to avoid the failures that still can happen.
Hey everyone, just quick time check. So we're about 5 minutes past the hour. We've got about 1 or 2 more questions that we're going to answer live right now from Michael and Giuseppe. But feel free, go ahead if you have any more questions. If these answers have spurred further questions, just enter those into the GoToWebinar panel, and we will stay online answering those for you as long as you like. So with that, let's do 1 or 2 more questions, and then we'll wrap up the live portion.
Okay. And I guess obvious and interesting question here is that does RightScale's management platform use different clouds as well? Basically, if Amazon goes down, does RightScale continue to work? Well, we do use different clouds, although I should say that at this moment, not everything is redundant. So, we have redundancy at many different levels, like different availability zones, many different replication strategies. But if the whole, EC2 East had to go down, which is really very difficult because there's 4 different availability zones there will be some parts of RightScale that wouldn't work quite yet.
Right. In that eventuality.
Right.
Of course, when you think about scenarios of outages, you can get all the way up to nuclear war, etc. So it's all a matter of degree. I would emphasize that, as Joseph pointed out, we are using multiple different availability zones and different cloud architectures to keep RightScale's uptime very, very high, and we do offer an SLA around that. Last question is, what's a good starting point for a multi-cloud deployment type of application or project to get started with this? What's a good sweet spot? Well, I think some of the examples that Joseph went into, anything that might be a collaboration application that you would need to launch in different areas, anything around development and test, so for dev and test environments, for R&D departments, QA, etc., launching in different locations. These also take advantage of the replicatability of server templates and deployments, so you can do a kind of a copy and paste operation to get entire clusters running in different clouds and different regions.
So I think that's something that somebody that has not really looked at yet could be a good starting point to browse. You can go to rightscale.com/library. You can see all kinds of things that people, all kinds of server templates that people have published that you could readily go and use and boot servers with like today. So you can go there and browse by categories. So you can boot up, I don't know, things like, I'm not really sure, everything that is there, but from PHP apps to Rails things, something that you can add a server with that template and boot up with your data, and then you're up and running with that technology. There's all kinds of good stuff that you can browse there.
Cool. Thanks, Giuseppe. Thanks, Michael. And thank you, everyone, for joining us. This concludes the live portion of our webinar. Again, you can stay online and ask questions. John Newton is there answering them for you. This webinar, just like all of our other webinars, has been recorded. It will be online within the next 24 hours. You can find it at rightscale.com/webinars, along with a complete library of all of the webinars that we have hosted throughout our years in cloud management. Thanks again for your time. Bye.